Hi everyone, hoping you all are doing well or great and studying well. Today I am going to discuss the very important topic from the wave optics, that is Heisen's principle of secondary wavelength or the secondary wavelength. First, the point comes on our mind, what is wavefront? Wavefront is defined as a continuous locus of a secondary wavelet which is defined at a particular instant of time with the same phase. This is called a wavefront. Wavefront are of so many types: circular wavefront, spherical wavefront, cylindrical wavefront. On the basis of the wavefront, Heisen's comprises the two principles. First is reflection proved by the wave theory, and second is refraction proved by the Heisen's principle. So first we will discuss what is Heisen's principle. According to the Heisen's principle, it means that at every point of time, the secondary wavelet is the source of the first wavelet. This means that XY is a plane and AB is an incident wavefront, and this point C is a reflected wavefront. On the basis of this, N is a perpendicular to this plane and this N is perpendicular to the second source of a wavefront. These are the two sources. On the basis of these two sources, because we know very well, this is a wave theory. On the basis of wave theory, what is wave? This is from a simple sinusoidal wave. How the waves are formed? Waves are formed in a fixed pattern. They follows the preceding particle with the same phase and with the same speed. Suppose we consider that this is a particle A, this is a particle B, this is a particle C, and here the particle is D. Means this is a particle with the same speed or with the same phase. This is called a wave. This is on the basis of Heisen's wave theory. The first wavelet touches the point B and then reaches the point C. It's on the basis of the wavefront because the secondary wavelets is the precedence of the first wavelet. From when the wavefront going from B to C, and the wavefront from going from B to C, it's acquire the secondary disturbance with the same phase. And when the point of the disturbance of the secondary wavelet from A to C, it acquire the distance A to C, it's attain the speed C and the time is T. So the distance is BD and AC equals to CT. Why? Because speed equals to distance upon time, and we know very well BD and AC is a distance. So C is a speed of light and T is a time. So on the basis of this concept, we have taken the two triangles A, B and C, and second triangle D, C, B. A, B, C, D, C and B. So on the basis of we want to prove whether it obeys the second law of reflection or not. So first, angle BAC, this angle, and CDB, both are 90 degree because we considered as both are normal. Then BC equals to BC. In these two triangles, BC are same. So BC equals to BC, common. AC and BD. AC and BD each is equals to CD. We already proved that. BD and AC equals to CT. C is the speed of light and T is a time. So by side angle side property, and triangle ABC and triangle DBC both are similar. If these two triangles are similar, this means that angle B and angle C are equal. If angle B and angle C are equal on the basis of same wavefront and the same plane XY, this proves that angle I or angle R is equal. And we know very well, if angle I and angle R are equal, this means that it obeys the reflection second law. What is reflection second law? Angle of incidence is always equals to angle of reflection, whether it is a ray optics or wave optics. So According to the Huygens theory, this also proves that whether the wave is a first wave or a second wave, it obeys the second law of reflection. So this is the first derivation regarding to the Huygens wave theory of a secondary wavelet. I hope you understand the concept. Thank you, students. We will discuss in our next topic, that is Young's double slit experiment. Thank you.